how I came to pre-flying.
Yes.
It was really a result of work we had done initially on jump parachutes, regular gliding sport parachutes. And that work was done in 1965, drop tested by NASA in late 1967 successfully. And we were actually in competition with a design by Regallo at that time. And they also drop tested their chute at about the same time. Both drops, I would say, were successful. And a few weeks later, NASA decided instead of using our chutes, they chose the shuttle and went from the Apollo to the current generation of all of the flights that I've made recently have been flight tests of new configurations.
Okay.
So can you tell us how did you arrive to the idea of slope soaring?
This was all preceded by the development of the sail wing as a jump chute. In fact, as part of the jump chute development, we had to have a way to steer it and to be sure that we could have stability during turns and doing flares for landing. the only way we could really determine a dynamic free flight type of condition without actually jumping out of an airplane at the time was to try to find an area where we could glide the chutes. One of the natural places for this was the ski slopes, and we went first initially to a place called Bel Air up in the Catskills. We did actually get just a foot or two off the ground. We didn't quite know how to go about getting the chute into the air, but after trying several ways that didn't work, we got around to holding the equivalent of the A-lines on the chute, and we were able to erect it that way, and then run like crazy, and sooner or later we got into the air. And at Hunter we were able to get high enough so that we could actually try some turns, and probably out of a sense of survival mostly, we learned how to flare the landings. We had to slow it down somehow. But that was the beginning of our slope soaring.
And you've been calling this slope soaring from the beginning?
Well, that was the only name that seemed to make sense, particularly on the ski slope. Yeah. This was the propeller that we used inside of an aerodynamically shaped shroud. And the only reason we used a shroud with the propeller was that we had to keep the diameter down for the particular design that we were aiming at. We went for the parachute because of an Air Force requirement at the time, in which we were trying to recover an ejected pilot, including his seat, so that he could fly about 15 miles, which was considered to be about as far as the pilots were likely to be from open water where the Navy could pick them up.
Do you think this was called the parachute? So
this is the propeller that we used on the test that we ran for the parachute.
Okay, and so this must be probably the first powered paraglider.
As far as I know, that was the first powered paraglider.
Same for slope soaring. It was the first time the activity called paragliding a little later was existing.
Right. As far as I know, that was the first time. Starting with the work that we had done at Hunter, it became clear that if we could do it there must be a lot of other places, other ski areas that were essentially idle in the summertime that would benefit from having another sport where the slopes could be used. And I mentioned this to a friend of mine who was the editor of Ski Magazine, and he got very enthused about the idea and sent me on a long-term search of ski slopes that were suitable for this activity. The slopes that we were able to find were relatively narrow, with large trees on all sides, and a couple of my landings were in the trees. We got involved in a about that time with the NASA contract for the large-scale gliding parachute. And because there wasn't any resort area that was suitable at that time, I shelved the whole project until there was more time to consider it.
So, can you tell us what, if we compare the sail wing to the actual paraglider, can you tell us what is similar and what is different?
Sure. Well, the basic idea of the original sail wing was to make something that was very simple and low cost. I was initially aiming for the sport parachute market and didn't want to get into something that was too sophisticated and too expensive. It happened that I had a small contract with the Army to develop a gliding device for a very small payload. In fact, the payload was of the order of 1 pound. And the chute I designed for that had a span less than 1 foot. We could tell from the wind tunnel tests that we did on that it did not have a wide range of angles of attack at which you could make it work, because it just like a sail, it works very well at one particular angle and one particular camber, and as you go away from that, you pick up a lot of drag. We actually did wind tunnel tests also under this Army contract in a size with a span of about 3 feet for a larger payload, and that was to be remotely controllable, so that we had to have good steering capability and be able to operate at a range of angles of attack. For that, we essentially built in a rounded leading edge as a means of getting a range of angles of attack out of it. And it was rounded by actually bringing the material around and having the length of the arc between the supports substantially shorter than the length of the arc of the top surface. And this did maintain its shape, particularly when we added supporting points behind the lower surface. From that particular design, the next step was a personnel-sized chute, which was indeed a single run of material with a rounded leading edge and with little catenaries to support the bottom surface. Eventually, in the summer of 1965, there was a national parachute competition run by Jacques Castell in Orange, Massachusetts. And all of the other competitive parachutes were of the round Paracommander type. And we managed to arrive while a bunch of these were in the air, and my test jumper, whose name was Guilfoyle, jumped out amongst the other chutes and proceeded to fly in circles around them. It made quite a good show at the time. We started discussions with NASA because in 1965 they were just about getting the Gemini capsules in the air with round chutes, and they knew that with the round chutes they were going to have to land in water, and they were looking for a way to have a better selection of a landing site. And we proposed to them a sail wing with a somewhat higher aspect ratio, which we proposed in a 90-foot inflated span. We eventually got a contract with them to build and develop and test this 90-foot chute, and that culminated with a set of drop tests at the Air Force Center at El Centro.
With an A in New York behind you.
And we were able to get very good phototheodolite data on those, on the large chute, and found at the same time that we deployed our parachute, we also dropped a type of parachute that dropped vertically, and then we measured both the motion of the parachute, of the glide parachute relative to the vertical flight, and that gave us a glide ratio of about 4.2.
4.2. So we had to wait more than 20 years to have the same glide ratio with paragliding.
So I heard. The development of the sail wing continued as a personnel chute for some time after that, and the rounded leading edge gave some flare capability, but by that time there were Jalbert chutes being jumped by sport jumpers, and to compete with those, we went to double surface chute with a fully enclosed leading edge with portholes for filling the interior of the chute. And that was roughly competitive with the Jalbert chutes. We didn't achieve a higher performance, and so there was no point to continuing that form of development. We were still working in other areas, and we didn't really know the extent to which paragliding had been developing during that period up until very recently, and it happened that I had to make a trip to Europe, during which I had a chance to watch the astounding developments in paragliding, and that really piqued my interest to the extreme.
So where was it in Europe?
Initially, it was in Switzerland, and we could see that it was a publicly accepted and very active sport. Sometime after that, we had the good fortune to go to Saint Hilaire, where we really were shocked to see how popular a sport it was. My thought at the time was that the progress had been tremendous, and 35 years had elapsed since I tried to slope soar, and I decided that I now had enough impetus and time to see what I could do, in the sport, trying to, I've actually designed gliders of my own, and unfortunately I no longer had any test pilots around. All of the flying on my gliders I've done myself.
Yes, it seems like you've always been flying on gliders you've been designing, but I know it's not true. You've been flying on a lot of other aircraft.
It happened that when I was about 18 years old, the government needed pilots far beyond what they had available at that time. For the immediate need was to have pilots to ferry the airplanes that England and France needed very badly at that time. It was just about at the beginning of hostilities in Europe, and they had a competition to put pilots through first the equivalent of a private pilot license, and I was able to qualify for that. And then the next step was acrobatic flying, and then cross-country flying, and then getting the requirements for a commercial license, and eventually instrument ratings. And about that time I got a job with Transworld Airways, who had a contract with the government to fly 4-engine aircraft for transoceanic flights. After that was a flight test engineer for Grumman, did some flying there. And just about that time, D-Day happened. The Army put me back through regular cadet training to become a pilot, and I ended up as a fighter pilot, and graduated as a second lieutenant on VJ Day. The war was over. The United States Air Force offered me schooling at their Air Force Institute of Technology, which was at Wright Field in Dayton, Ohio. During that time, I continued flying. After completing the Air Force Institute of Technology, which gave me the equivalent of a bachelor's degree, I was sent to the California Institute of Technology, where I got a master's degree in aeronautical engineering, and then a professional degree in aeronautical engineering. After that, I was sent back to Wright Field and worked as a theoretical aerodynamicist, primarily in wind tunnel. I stayed at Wright Field for 3 years and then resigned the Air Force. Much of my next couple of years was spent as a consultant, primarily to the Air Force and also to several of the aircraft industry companies. I decided that there was a better way to make military parachutes. There was a phenomenon in auto-rotating parachutes called the Vortex Ring State, which is a means of substantially increasing the effective drag area of a parachute made of relatively slender blades, which produce the same drag as a round chute of the same diameter, using much less than half the cloth area. And of course, that meant less weight, less cost, and a great deal of my time during the next few years was spent in developing devices of this type.
Et on reprend là.
Allez les gars,
personne qui est assez âgée et donc on passe d'une belle jeune femme de 24 ans, pas plus, et donc il faut le faire à passage. Un tout le monde l'histoire, et on voit
Okay, I'm finished.